Now, where we use this in this class is to find something called the consumer surplus. Suppose the supply function for oil is given in dollars by S of Q equals Q squared plus 10Q. So if I put in a quantity here, this tells me the price at which manufacturers are willing to supply the oil. The demand function is given in dollars by D of Q equals 900 minus 20Q minus Q squared. And if I put in a quantity of oil here, this tells me the price at which consumers will demand that quantity. So the first thing we're going to do is we're going to find the location of the equilibrium point and interpret its meaning. Here I have my two curves, and the equilibrium point occurs at the point of intersection. We can see that that point of intersection is approximately 15, 400, but let's be careful and find that algebraically. So what I need to do is I need to set the demand curve equal to the supply curve and solve it for Q. D of Q equal S of Q. And now I'll put in my two functions, 900 minus 20Q minus Q squared equals Q squared plus 10Q. This is a quadratic equation, and in order to solve it, I need to move all the terms to one side so that this is set equal to 0, and then I can either use the quadratic formula or I can factor it. So what I'm going to do is I'm going to add Q squared to both sides. I'm going to add 20Q to both sides. And I'm going to subtract 900 from both sides. So I'm going to put everything on the right-hand side. When I do that, I get 0 equals 2Q squared plus 30Q minus 900. Now I see some factors here that might be able to be factored out, so let's go ahead and pull out a 2. So that leaves me with 0 equals 2 times the quantity Q squared plus 15Q minus 450. And I'll factor the quantity here that I see in parentheses to give me 0 equals 2 times the quantity Q minus 15, Q plus 30, and we'll check it. The inside term is minus 15Q. The outside term is plus 30Q. That gives me the 15Q. Last times last, minus 15 times plus 30 gives me minus 450. So this is the proper way to factor this. If this hadn't worked, I could always fall back to the quadratic formula. I'll set each one of the factors equal to 0. So when Q minus 15 is equal to 0, we get Q equals 15. And when Q plus 30 is equal to 0, we get Q equals negative 30. 2 can't equal to 0, so I'll go ahead and ignore that. So I have 2 points of intersection, and only one of them, the Q equals 15, is one that makes sense for this problem. So when I put 15 into my supply curve, I get 15 squared plus 10 times 15, or 375. So the point of intersection here is 15, 375. What that means is at a price of $375 and a quantity of 15, consumers will purchase the same amount of product that the manufacturers want to sell. So if I go ahead and look at this and say at a quantity of 15 and $375, that means 15 times 375, I'll receive $5,625 for the sale of those items. This is simply the area of the green box that we see here. In other words, finding area allows me to find the total amount of money that comes from the sale of those items. In this case, if we sell 15 items at $375 a piece, we get an area of $5,625. The key thing to notice here is because our demand curve is much higher than that 15,375, some consumers would be willing to spend more than that item for the equilibrium price. Some consumers might be willing to spend as much as $800. How does this affect the market? Well, the total of the differences between the equilibrium price of the oil and the higher prices that individuals would be willing to pay is thought of as savings realized by those individuals and is called the consumer surplus. It basically amounts to the area under the demand curve and above the price that they would be willing to pay at equilibrium. So to understand this, let's take a little bit closer look. So first, let's look at the area under the demand curve. Now, we said that area represents the total amount of money that would be paid by those consumers. So if I find the area under this curve, that tells me the very most that someone would want to pay for 15 items. If they pay the equilibrium price, they'll pay a lot less, but if they follow the demand curve paying these prices, the most that they would pay is whatever the area of this region is. Remember, the green area, the 5,625, is what they would pay if they paid the equilibrium price. The area is less than the total area under the curve, so they're going to actually save themselves some money by paying the equilibrium price. And the amount of money that they're going to save is the difference between the area under the demand curve and that green area. And so since they're saving money, that's thought of as a consumer surplus. So basically, if D of Q is a demand function with an equilibrium price P sub 0 and an equilibrium demand Q sub 0, then that consumer surplus is simply the difference between those two curves, the difference in the areas. So that means the definite integral from 0 to Q sub 0 of the quantity D sub Q minus P sub 0 dQ. So this is just the difference in the areas under the demand curve and under the equilibrium price. So let's go ahead and find that in this case. Our equilibrium quantity was 15, so we have to find the definite integral from 0 to 15, and we have to take the demand curve minus the equilibrium price, so 900 minus 20Q minus Q squared, and then subtract 375, and we're going to be integrating with respect to Q. So if I combine my like terms together here, I get a definite integral from 0 to 15 of the quantity 525 minus 20Q minus Q squared dQ. And now I'm going to apply the fundamental theorem of calculus. I'll find the antiderivative and then evaluate this at 15 and 0 and subtract. So the antiderivative is 525Q minus 10Q squared minus Q cubed over 3. And the fundamental theorem of calculus says evaluate that over 0 and 15 and subtract. So when I do that, I get the quantity 525 times 15 minus 10 times 15 squared minus 15 cubed over 3. And when I put in 0, I get 0. If I work out the arithmetic, I get 4,500. So by paying the equilibrium price instead of following the demand curve, the consumers actually save $4,500.